This is an object of mass m which is attached with a light string. It is rotating in a horizontal circle. And in this question, you have to find out the tan theta. And this mass is executing this rotational motion with an angular speed omega. So what is omega? Omega tells us that how fast or slow body rotates in per unit time. So this is simple understanding of omega. And now for first of all, we have to make a free body diagram. So at this point, there is a one force, that is a force of tension, that must be larger than the weight acting on it. Why? Because when we will make the components of force of tension, for example, like this, so this is the one component of force of tension. This is theta, this theta, and this theta are both exactly same. So adjacent component is always cos component. So this will be ft cos theta. Whereas the other component that is directed towards center is ft sine theta, and it is not balanced by any other force. So basically there are only two forces acting on this mass, and these two are the components of force of tension. So in rectangular coordinate system, we see that the force that is acting upward is equals to the force that is acting downward. So the ft cos theta is equals to mg, but this force is not cancelled by any other force. So this force should be the resultant force. So its magnitude is equals to ma, which is actually the centripetal force. So you can also say mv square over r. Now we can represent the velocity v in the terms of angular velocity, because v is equals to r omega, and it will become mr omega square ft sine theta. So these are the two equations that we have, 1 and 2. So if we divide these two equations, because we want to find out tan theta, over ft cos theta is equals to mr omega square divided by mg. So we see that the force of tension, which is already unknown, it's cancelled out. So we have the tan theta equals to r omega square over g. So the right answer is option A, omega square r over g.